Welcome to the last part of the first example on quadratic inequalities. In the previous video, we were trying to solve this inequality right here, which is x squared plus 2x minus 24 is greater than or equal to 0. And then we said that this expression here, x squared plus 2x minus 24, is simply a parabola. It's a quadratic function. It's a quadratic graph. So if we draw this graph, x squared plus 2x minus 24, this one right here, we get this parabola with these 2 points, -6 and 4, going like this. So basically, this expression here, as I mentioned in my previous videos, represents the y-coordinates of this parabola here. So we are looking for a region of x, because remember, this inequality, the solution is x. They are x values. So we are looking for x values which are inside the region where the y-coordinate of this graph are greater than or equal to 0. And it's these regions and these regions. This region here is not a solution, because in this region of the graph is less than 0. The y-coordinates of the graph are less than 0. But if you look at this region here, all the x values that you pick, they have y-coordinates which are greater than 0. Same applies in this region. All the coordinates of x that you pick here, they have y-coordinates which are greater than 0. So common sense would then tell you that the first solution is x greater than 4. X greater than 4. Why? Because if you x values to this right are x values that are greater than 4. And if you take any x value greater than 4, it's in this region, and in this region, the y-coordinate of the graph is greater than 0. But hold on, greater than or equal to 0. Greater than or equal to 0. What that means is our solution should also include x values such that if we take those x values, the y-coordinate is 0. And those x values are 4 and -6. So we need to put this sign right here to say x is greater than or equal to 4. X is greater than or equal to 4. Because if we say x is greater than or equal to 4, if x is equal to 4, this inequality is satisfied, because the y-coordinate would be equal to 0. Because this, remember that what this means is just that f of x should be greater than or equal to 0. So we want x values that will make f of x 0, or x values that will make f of x greater than 0. That's what this or equal to means. So that's why we have to put this inequality sign here to say x can be greater than 4 or equal to 4, because if it is equal to 4, our f of x does become 0. But if x is greater than 4, then our f of x is greater than 0, which is the one at the top. It's greater than 0, because if you take all these values here, f of x is greater than 0. And again as well, we want x values to this side, x values which are less than this -6. Remember, as we go this side, we're going to x values which are less than -6. If we take any x value that's less than -6, f of x is going to be greater than 0. As you can see, this graph just keeps on going up. The y-coordinate will always be greater than 0. So the second solution is x is less than -6. But we put that sign there because if x is equal to -6, if x is equal to -6, which is the bottom one here, equal to, then our f of x is 0 and the inequality is satisfied. But if f of x is less than -6, if f of x is less than -6, we are going to this side, and as we go this side, our y-coordinates are constantly less than 0. So are constantly greater than 0. So f of x will always be greater than 0. So these are the two solutions to this quadratic inequality. If we pick x values which are greater than 4, our function f of x is going to be greater than 0, because anything greater than 4 going this side, here's our graph, and the graph is always greater than 0. But if we do pick x as 4, which is shown by this sign here at the bottom, that if x does equal to 4, then our f of x is equal to 0. The y-coordinate is 0. It's on the axis. The y-coordinate is 0. So this inequality, again, is satisfied because f of x is allowed to be equal to 0, because it's greater than or equal to 0. Same applies here. Same applies here. X is less than -6. If we pick x values which are less than -6, -7, -8, and so on and so forth, the graph just keeps on rising up and up and up. And we notice that the y-coordinates of that graph will always be greater than 0. So f of x will be greater than 0. So if you pick any x value that's less than -6, it will give you a y value that's greater than 0. So it will be satisfied. But or equal to, x is allowed to be equal to -6, because if it is -6, then the y-coordinate is 0. And our inequality says f of x is allowed to be equal to 0. So that's what happens. What we're basically trying to say here, just to conclude this video, what we're basically trying to say is, if we pick any x value that's greater than -6, but less than 4, if we pick any x value that's greater than -6 but less than 4, or basically in this region here, greater than -6 and less than 4, if we pick any x value in this region, it's not going to satisfy this quadratic inequality, because if we pick any x value in this region, our function f of x or our function y is going to be less than 0. As you can see, this part of the graph, it's below the x-axis, so every single y value in here is negative, it's below 0. So if we pick any x value inside this region, this inequality will not be satisfied. So we just want x values in that region and that region, because if we pick x values in those regions, our function is going to be greater than or equal to 0. Until next time, thank you.